right, happy Monday, everybody. Today we are going to look at graphing lines just like we did last week. I have my table set up for you. So what we're going to be doing is taking some x values, inputting them into the function, getting a y value, and then writing it as ordered pairs and plotting it on the graph. So we're looking to do exactly the same thing we did last week. The only thing that's going to be different is at the end, we're going to be comparing and seeing if we notice any patterns happening. But otherwise, I just want you to keep practicing inputting some values in for x and graphing these lines using tables. So let's go ahead and get started. What I need to do first is take this x value and input it in for x. Now, in the skills quiz, I noticed a few of you guys were a little bit confused with this still. I tried to find you a cool schmoot video, but honestly, they didn't do a great job. They almost made it more confusing. So that is just a notation. It's just a way of writing. It's a function of x. If that makes you uncomfortable, just ignore it. You can literally just ignore it and think of this expression instead. So we're plugging -2 in for x. So we can say we need 3 times -2. So if that function of x thing just stresses you out, like I said, just get rid of it. 3 times -2 is -6. If you want to write your ordered pair right away, we're going to say we inputted -2 and the output was -6. So -2, -6. Okay, so we're going to do the same thing for the next one. We're going to input -1 in for x. Again, just ignore this if it's bothering you. We're looking at 3 times -1. So that's going to give me a -3. So my ordered pair would be the input value -1, the output value -3. Next is 0. When I input 0, it's just 3 times 0 for this function. So that's a 0. And my ordered pair is 0, 0. Next, we want 3 times 1, which is 3. And my ordered pair becomes input value of 1, output value of 3. We've got 1 left. 3 times +2. My output is 6. So my ordered pair, input, output, would be 2, 6. So let's plot this on the coordinate plane. I'm just going to plot these points. Remember, it's x and then y. So -2, -6. Then I need -1 and -3. 0, 0. 1 and 3. And 2, 6. Just going to connect those points. Just going to draw our line for us. And then I just want to look at a couple of features of this linear function. So last week we talked about the rate of change. So how does this thing change as we go from left to right? So if I'm looking this direction, right, from left to right, this thing is going up, which means I'm going to have a positive rate of change, positive slope. It's a steep line, and let's talk about exactly how steep. So we're just going to pick 2 points, and we're going to say how far up and over would you have to go to get from one point to the next. Pick any points you want. I'm going to go with these 2. To get from here to here, I would have to go up 1, 2, 3, so +3 because we're going up, and right 1, which is in the positive direction. So if I were to write this as a rate of change, I'm going to do the change in y, so how far up we go would be +3 over the change in x, and 3 divided by 1 is 3. So that's my rate of change. We also call that the slope. So the slope of this line is just saying that to get from one point to the next, you're going to go up 3 units and over 1. If you had chosen different points, it would be okay. Let's say we picked this one and this one. We would go up 6 units in the positive direction, and we would go over 2 units in the positive direction. And 6 divided by 2 is still 3. So our slope is the same. So slope or rate of change is +3. Now, there is another way to do this. We could go from left to right. It's not wrong. I just prefer not to do it. But if we went left to right, we would have to go down 3 and left 1. Now, if you're willing to think about this for a second, watch what I'm going to do. If you're a little bit confused, just ignore me for a sec. If I went down 3, that would be the negative direction. And then I would have to go left 1, which is also the negative direction. Negative 3 over negative 1, also positive 3. So let's clean this off because I don't want it to look too confusing. We've determined a couple of different methods, and we have said the slope is 3. So my rate of change, how far up and over I have to go to get from one point to the next, is 3. The next thing I want to look at, I'm just going to rewrite this. So M stands for rate of change. I know it doesn't actually seem like it should, but it does. The next thing I want to look at is where it's crossing the y-axis. Remember, the y-axis is this one that's going up and down. Oh my goodness, that's a straight line. It's crossing right here at 0. Right? So our y value is 0 where it's crossing. This is called a proportional relationship. This would be something like for every, I don't know, for every 3 Easter eggs my brother got, I got 1. Or, I don't know, something along those lines. So if you were to plot that, I got 1, my brother got 3. I got 2, my brother got 6. So proportional relationship. They are proportionate to each other because it's just a number multiplied by a constant. Let's look at another one. You know what I forgot to do? Look back at our notebook for a second. We forgot to recognize something. We said that our rate of change was 3, right? So I just want you to look at that number in our equation. Also, our y-intercept we said was 0. Last week I was showing you where to find both of those numbers in the equation, but you don't see a 0 anywhere. It's right there. There's nothing added or subtracted to the end, which means it's a 0. All right, next one, we have a fraction. So if you notice the x values I chose, I picked something a little bit different this time, mostly because I didn't want to be inputting a negative 2 in here and then having to multiply it by a fraction. So I chose some different values that I thought would make it a little bit easier for us to do the math. So let's input some stuff. Remember, if you don't feel comfortable with the function of x notation, ignore it. And we are looking at 1/4 times negative 8. So 1/4 of 8 is 2, and I have a negative. Let's do it again. We're looking this time at 1/4 times negative 4. Positive times a negative is negative, and 1/4 of 4 is 1. Next one, we're going to be doing 1/4 of 0, but anything times 0 is 0. Next I have a positive 4, so we're doing 1/4 times 4, and that's positive 1. And finally we need 1/4 of positive 8, so that gives us positive 2. I'm going to write in my ordered pairs. So input and then output, negative 8, negative 2. Next I have negative 4 and negative 1. We have 0, 0, 4, 1, and 8, 2. I'm just going to plot those on my coordinate plane. So back 8 in the x direction, down 2 in the y direction. There's my first point. There's negative 4, 1. Here's 0, 0. We're crossing right there at 0 again. 4, 1, and 8, 2. I'm going to draw on my line, and we'll look at the features of the graph. Okay, so first thing, as we're looking from left to right, we have a positive rate of change, positive slope, because it's going up. And let's look at exactly how steep this line is. It's definitely not as steep as the last one, so we can expect to have a lower number. And let's pick some ordered pairs. I'm going to go from maybe this one to this one. So going from left to right, giving directions, I would have to go up 1 unit, so that's the positive direction, and right 4 units, again the positive direction. Be careful when you're writing this as a ratio. I know it's probably habit for us to take the bigger number on the top, but you need to put what's happening in the y direction on the top of the fraction. So we're going to deal with this more later, but rate of change is actually calculated by change in the y value divided by change in the x value. That little triangle means change. So if I'm looking at how far up I would have to go, it's +1, and how far over is +4. That is my rate of change. That's my slope. If you're thinking that you wanted to pick other ordered pairs, again, it doesn't matter. Let's say I did this one. From here to here, I would go up 2 units and over 8 units to the right. So change in y divided by change in x, and we would still get that same 1/4. So back on our paper, we can say our rate of change is 1/4. Hopefully you're starting to see this pattern. My rate of change being 1/4, you can find that number right here. Next thing we're gonna look for is our y-intercept. I wanna know where this is crossing the y-axis. So here is my y-axis, and my function is crossing right here at the origin again. So I'm gonna say my y-intercept is 0, which we could have predicted, because just like last time, there's nothing added or subtracted to the end of my equation, which means it kind of has this invisible +0. Okay, so we've got 2 equations so far that both went through the origin, which means they are both proportional relationships. So in this, the y value is exactly 1/4 of the x value no matter what x was. Nothing's added or subtracted, so it's predictable and it's proportionate. Okay, we've got one more, and then you guys are on your own. So in this next one, we've got something a little bit different. We're looking at f of x is equal to -5. So I'm gonna just go ahead and input my values. Oops, there should be an x there. So -5 times -2. So my output is +10. You can write your ordered pair now if you want to. We've got -2 and 10. Next, I have -5, and I'm going to be inputting an x value of -1, which would give me +5. So my input was -1, my output is +5. Next, I'm going to input a 0 in place of x. -5 times 0 is 0. So we're looking at -5, 0, 0 as my ordered pair. Now we've got -5 times 1, so my ordered pair is 1 and -5. And then our last one, -5 times 2. So my output value is -10, and my ordered pair is 2, -10. So I'm just going to plot all of these points. Then we're going to look at the slope or rate of change and the y-intercept. So -2, -10, -1, -5. 0, 0 again. Hopefully now you've seen this pattern. All of our proportional relationships are going to cross through the origin. What am I doing? Oh my goodness. That never happened. This should have been -2, +10. If we were in class right now, you guys would have totally caught that. -1, +5 through the origin. Now we've got +1, -5, and +2, -10. All right, that made a big difference, because now as we read our line from left to right, it's going down, which means we have a negative rate of change or a negative slope. So let's look at a couple of things. First thing I want to look at is our slope. So we know it's negative, so we should anticipate having a negative value as a rate of change. But let's look exactly how steep this thing is. Let's go from here to here. So I would have to go in the y direction down 5 units, so that's the negative direction, and right 1 unit, which is positive. So when I write my rate of change, it needs to be a fraction, the change in y value divided by the change in x value. -5 divided by +1 is -5, so that's my slope. You could have picked any 2 points, it wouldn't matter. As long as you simplify it, we're going to get -5 no matter what. So back on my paper, I'm going to say my rate of change was -5. Hopefully you're starting to see this pattern. Right? If we're looking for rate of change, go back to your function. Hopefully you'll find it. And the last thing we're looking for is where this thing is crossing your y-axis. So again, y-axis is the up and down axis. It's crossing right here at the origin, which means our y-intercept is 0. So something all of these problems had in common is that every single one of them has a y-intercept of 0, and if you look back in the function, there was nothing added or subtracted to the x. So these are all proportional relationships. Every single one of them crosses through the origin, and they are all in the form of y equals something times x. All right, you guys are ready to try some on your own. So at this point, you can pause the video. I'll show you the problems. So go ahead and pause right here. You're going to try these on your own, and then you can hit play when you're ready for the answers.